As we work with quadratic equations, we sometimes see that it doesn't have a real solution. So let's just go over how to work with complex numbers again, because we will start seeing those when we're solving quadratic equations. So the complex numbers come from solving a quadratic equation, let's say like this. So if we have x squared plus 5 is equal to 0. Well, when we either try to factor it, and we say, oh, we can't factor it, so we'll just go ahead and try and solve it. So we'll subtract 5. And we're looking for a number squared that will equal to a negative 5, and there isn't one. So that then, mathematicians expanded the definition of, creating some more numbers so that we can solve an equation like that. And that's where the set of complex numbers was born. And the standard form for a complex number is the form a plus bi, where a is the real part and b is the imaginary part of your number. So for example, in the complex number in standard form, 2 plus 3i, 2 then is the real part, 3 is the imaginary part. If the real part of it is 0, so like if we have 0 plus 4i, anytime that real part is 0, then we say the imaginary number, or the complex number, is pure imaginary. So just like a 4i, a 2i, a 6i, those are referred to as pure imaginary numbers. So now if we go back over to this quadratic then, and we take the square root, so I want this to be equal, it's equal to plus or minus then the square root of negative 5. So then we'll break this down, and we'll think of negative 5 as the product of negative 1 and 5. So we're not going to take the square root of the 5. We're going to leave that underneath the radical sign. And then the square root of negative 1 is I. So that's how we will show the solutions then to that quadratic equation. Adding and subtracting complex numbers is fairly simple. It's just like combining like terms, when we're working with variables. So if I have 2 plus 3i, so there I have an imaginary number in standard form. And let's add it to another one in standard form. Let's say 6 minus I. So the real parts are the 2 and the 6, so we add those together. So the real part of our sum is 8, and then we add the imaginary parts. So 3i minus I is plus 2i. You could add a pure imaginary, so let's say like 5i plus 2 minus 7i, and that would give us 2 minus 2i. Let's try the difference. Let's say that we have 3i, so there's a pure imaginary number, and we want to subtract from it the complex number 2 plus 2i. So once again, remember we're subtracting both the real and imaginary parts. So this is critical. You guys need to remember to distribute that negative sign. So we get 3i minus 2i, so that'll be I. And then we get negative 2. Okay. Well, in order to put it in standard form, we need the real part first of all, so we'll put the negative 2 in front, and then we'll put the imaginary part at the end. So there's the difference in standard form. Let's take 3 plus 2i, and we want to subtract from that complex number. Let's go 6 minus 5i. Okay. So we want to go 3 minus 6, so that will give us a negative 3. And then we also want to go 2i minus negative 5i. So we're actually adding 5i to 2i, so it would be plus 7i. So we're getting at the point here where I expect you to know how to distribute and take care of that. And on a quiz or a test or something, if you didn't distribute to that second part correctly, I will take all the points off for that. So you guys need to pay attention to that detail. Let's try this one. 3 plus 2i. Let's add 1 plus 4i. And then let's subtract also at the same time 2 minus I. All right, so as we work across, we look at the real part. So we've got 3 plus 1, so that gives us 4, and then subtract the 2. Well, that will give us a positive 2. And then 2i plus 4i is 6i minus negative I. That gives us another plus I, so we get 7i then. So there's our solution again in standard form. The real part first, the imaginary part second. In this set of complex numbers, if I ask about the additive inverse or the additive identity, that is, well, it's similar to when we're working with real numbers. So the additive inverse is what do we have to add to a number in order for it to equal 0? And for a plus bi, if we want to know what we have to add in order for it to equal 0, well, we have to add the opposite of the a plus the opposite of b. So that's the same thing as minus bi. So negative a minus bi would be the additive inverse. Whereas the additive identity is exactly the same thing it is in the set of real numbers. So we're saying, what do we have to add to a complex number in order for it to stay exactly the same? And that would be 0. So 0 is the additive identity of any complex number. All right, now let's try multiplying some complex numbers together. Let's start off with maybe doubling a complex number. So let's say we have 3 minus 5i, and we want to multiply it by 2. Once again, we need to distribute, so we get 6 minus 10i. If I multiplied by a pure imaginary number, and I multiplied it to the complex number, let's say 2 minus 3i. We're going to take 3i times 2 first of all, so that is going to be 6i. And then we're going to multiply 3i times 3i, and we'll get 9i squared. And then we're going to simplify it, put it in standard form. Well, if the square root of negative 1 is I, then remember I squared is negative 1. So if I squared is negative 1, we take out this I squared, we put in a negative 1. So negative 1 times negative 9 is positive 9. So that becomes the real part, so we'll list it first. And then 6i is the imaginary part, so that goes at the end, so that we have it in standard form. Let's say we want to take 4 minus 2i times 1 minus 3i. Well, in this case, we treat it as we would multiplying two binomials. So we've got to double distribute here. We've got to multiply the 4 times the 1, the 4 times the negative 3i, so that'll give us negative 12i. Then we have to take negative 2i times 1, so that's negative 2i. And then we have to take negative 2i times negative 3i. Well, that is plus, negative times negative is a positive, 2 times 3 is 6, I times I is I squared. Alright, so we're going to take a look at that I squared. Once again, I squared is negative 1, so I squared becomes negative 1 down here. 6 times negative 1 is negative 6. So I can combine the negative 6 with the 4. So 4 plus negative 6 is negative 2. So I will list it first, and then I'm going to combine the imaginary parts. So minus 12i minus 2i is minus 14i. Okay. How about multiplying, let's say, 5 minus 4i times 1 plus I. We'll practice another one of these. Once again, this is a double distribute. 5 times 1 is 5. And then 5 times I is 5i. And then we'll multiply by the negative 4i. So negative 4i times 1 is negative 4i. And negative 4i times I is negative 4i squared. That I squared becomes a negative 1, so we're taking negative 4 times negative 1. That changes this to a positive 4. So I can add that positive 4 on to the 5 to get 9. And then I combine the imaginary parts. 5i minus 4i is 1i. And 1i, we can just show it as I, just like we would a 1x. All right. Complex conjugates. Sometimes when we're multiplying, we come up with an imaginary number like this, and if we multiply it by its conjugate, which is 3 minus 2i, we end up with the real number. So let's take a look at what happens here. So it's a double distribute again, so 3 times 3 is 9. 3 times negative 2i is negative 6i. And then I multiply the 2i. 2i times 3 is plus 6i. And then 2i minus times a negative 2i is minus 4i squared. We'll take a look what happens to the negative 6i and the plus 6i. Those are just the opposites of each other, so it's going to cancel. So we're losing that imaginary part. Over here on that last term, the I squared is a negative 1. So we're actually taking negative 4 times negative 1, just like we've done in the last few screens. So that'll change that to a positive 4. And then we can add the positive 4 to the 9. So we end up with 13. So when you multiply conjugates, it turns into a real number. All right, so if I gave you the number 4 minus 5i, the conjugate of 4 minus 5i, the 4 stays the same, so it's a positive 4, and then you just change the negative 5i to plus 5i. So that gives us our conjugate. So now, when I multiply here, a negative 5i times 4, I get a negative 20i. Here I get a positive 20i. So the imaginary parts cancel out. So now I just have to look at the 4 times the 4 and the negative 5i times the 5i. So negative 25i squared. Don't forget we have the I times the I, so it's I squared. And then once again, there's that I squared. I squared is a negative 1. Negative 1 times negative 25 gives us a plus 25. And when we combine these two, we end up with 41. So now we're back to a real number again. We don't have an imaginary part to it. Okay? So what would the conjugate of negative 2 minus 3i be? Well, we keep the negative 2, and we just change the sign on the last one, so it would be 3i. All right, so let's try multiplying then. Look right here, and we see that negative 3i times a negative 2 gives us a positive 6i. And when I multiply here, a negative times a positive gives me a negative 6i. So those, once again, are going to cancel. So now if I multiply negative 2 times negative 2, I get positive 4. And then negative 3i times 3i, we get negative 9i squared. So it's important to remember that I squared, because it's I times I. Negative 9i squared becomes plus 9. So 9 plus 4 is 13. Okay? Complex quotients then. So when we're dividing imaginary numbers, let's start off with something like 3 plus 2i, and we want to divide it. Let's keep something fairly simple. Let's just say by I. Okay, well this is like having a radical in the denominator. It's the square root of a negative 1, so what we do is we just multiply it times itself. So we just take I times I, so that means on top we have to multiply by I. So anytime we're multiplying a fraction, just to change the look of it but not the value of it, we can multiply by like anything over itself, because that's equivalent to 1. Alright, so on top then, when we multiply by I, we have to distribute. So we've got to take 3 times I, so we get 3i, plus 2i times I. That will give us 2i squared. In the denominator then, I times I gives us I squared. And what we like about that is that I squared is equal to a negative 1. So our denominator becomes negative 1, so we no longer have a radical down there. In the numerator, we can't do anything with the 3i. The 2i squared, we change to a negative 2. Now we are going to divide by that negative 1. So it's going to change the 3i to a negative, and it's going to change the negative 2 to a positive 2. So as we're switching that around then, as we divide, I'm also going to switch it around. And I'm going to put the real part first. So negative 2 divided by negative 1 is positive 2. And positive 3i divided by negative 1 is negative 3i. So if we're dividing by negative 1, both the signs have to change in the numerator. So this will become positive, and this will be, this will become negative, and this will become positive. So then I switched it around and put the 2 first. Okay, let's try this one then. Let's say we have 3 plus 2i, but instead of just an I, let's divide it by 2 minus I. So our goal is to get rid of that imaginary number in the denominator, so we're going to multiply the 2 minus I times its conjugate. So we're going to multiply by 2 plus I, because we already saw on that last screen how it changes it to a real number. So in the numerator then, we have to multiply by the same thing, 2 plus I. In the numerator, it's a binomial times a binomial, so we have to double distribute here. So I've got to take the 3 times both the 2 and the I. So 3 times 2 is 6, 3 times I is 3I. Then we take the 2I times both of them. 2I times 2 is 4I. And then 2I times I is 2I squared. Okay, in the denominator, negative 2I and positive 2I are going to cancel each other out. So we're just going to take 2 times 2. That'll give us 4. And negative I times I, which will give us minus I squared. Because I squared is a negative 1, we end up with 4 minus negative 1, which is 5. So that'll give us a 5 in the denominator. Now let's simplify our numerator. So 2I squared changes to a negative 2. So 6 plus negative 2 is 4. And then 3I plus 4I is 7I. Now, if they want it in the form a plus bi, that means we have to separate it into two numbers. So the real part is 4/5, and the imaginary part is 7/5 I. Okay, so there we have it, even in standard form. All right. So if you have an imaginary number in binomial form, you know, with both the real and the imaginary parts, then you need to multiply by its conjugate to get it out of the denominator. Why don't you try this one then? How about if I give you 5 plus 7i, and then I want you to divide it by 4 minus 2i. Okay, so that'll be one for you to practice then. So when you get done with this, or you can pause it right now. Let's take a look at complex solutions. So if I have the quadratic equation, let's say 3x squared minus 2x plus 5. Well, usually what we do is we look to see if we can factor to find our solutions. So we would look for factors here. We've got to have a 3x and an x. And then factors of 5, just 5 and 1. That's our only thing. So we can have 1 here and 5 here. I know because this is a positive, they have to both be the same sign. So both positive, both negative. Well, if they're both positive, I would get a 15x and a 1x. And if they're both negative, I get a minus 15x and a minus 1x. Well, that doesn't give me that negative 2x. So I can try putting the 5 here and the 1 here. Okay, then when I multiply here, I get a 3x, and when I multiply here, I get a 5x. Well, they either both have to be positive or both negative, so when I add, I'm either going to get a negative 8x or a positive 8x. So I can't finagle this and get a negative 2x. So that means we can't factor it, so we have to solve it some other way. So we'll use the quadratic formula. Remember, 3 is our a, negative 2 is b, and c is 5. So the quadratic formula says take the opposite of b, so the opposite of negative 2 is positive 2, plus or minus the square root of b squared. Now remember, it's the whole b, so it's always, when you do this piece of it, it's always going to be a positive number. Because if your b is negative, like it is up here, when we multiply negative 2 times negative 4, we get positive 4. Once again, let me emphasize, this is always going to be positive. And then minus 4 times a times c. Okay, and then it's all over 2 times a. All right, so those are our solutions. So our x is equal to these two numbers here. All right, so we've got to simplify it a little bit. So underneath the radical sign, we've got to take 4 times 3 times 5. Well, the order that we multiply doesn't matter, so let's take 4 times 5 first of all. 4 times 5 is 20, and then multiply that times the 3. So the product then of all of those together is 60. So underneath the radical sign then, we end up with 4 minus 60. And that gives us a negative 56. All right, so let's come down here then and let's write 2 plus or minus the square root of negative 56 all over 6. Well, anytime we have radicals, we want to completely simplify it. So I see that I have a negative underneath the radical sign, so I am going to show a negative 1 as a factor. So we have a negative 1. And then 56, we're looking for a number that's a square, like 4, 9, 16. And sure enough, 4 is a factor. So 4 times, you know, when I'm looking at this, we're saying, well, what do we have to multiply by 4 then to get 56? Does anyone know what that is? We should get 14. So I take the square root of a negative 1. So that becomes an I outside the radical sign. I take the square root of 4 and I get a 2. That moves outside the radical sign, but I can't do anything with the 14. So now our numerator, we're looking at 2 plus or minus 2 square root of 14i. That's just our numerator. Remember, it's still all over 6. Okay? And then we also remember that the only way we can reduce it is if we can factor something out. And yes, I can take a 2 out of both of the terms here. So if I factor out a 2, yeah, I know I'm running out of room. Let me grab another color. So I'm going to factor out a 2 out of the numerator. And 2 divided by 2 is 1, plus or minus the square root of 14i all over 6. Now, because 2 is a factor, I can reduce. So I reduce, and I get a 3 down here. So our last step is going to be to put it in standard form, which is once again is a plus bi. So in standard form, it looks like we have a 1 over 3, so the real part is 1/3. And then plus or minus the b, well, the numerator is the square root of 14, the denominator is 3, and then we have the I at the end. All right, so there is our complex solution to that quadratic equation. All right, so and come on, green. Let's bring up the credits here as we close. So good job, and we'll practice some more of that when we get to class. So make sure and rewind it, look at stuff again. If you had any questions on it, that's what you're going to ask me in class also. All right, see you then.